So for today, we're going to talk about evaluating limits containing trigonometric functions, and this is still a part of a differential calculus video. So for today, we shall be solving 6 problems involving trigonometric functions, involving the limits of the trigonometric function. So let's get started. So for this problem, we have the limit of the tangent squared x multiplied by sine 3x over secant x over 2 minus cotangent of 2x. So as x approaches pi over 3. Okay? So this pi over 3 is converted into degrees. We have 60 degrees. Okay? And in evaluating this limit, we must know at least the value of pi over 3 in all of the trigonometric functions involved in the limit. So what are we going to do is to simply recall our uh, special triangle, okay, wherein we have, let's say we have 60 degrees here, we have 360, 90 degrees, we have a right triangle here, and we know that the value of this is 1, we have the square root of 3, and we have 2. So if we get tangent of 60 degrees, that is square root of 3. Okay, that's TOA. Opposite square root of 3 over adjacent is 1. So we have square root of 3. And we have cosine of 30 degrees. Okay, because we have secant here, we can convert this into cosine, and this cotangent into tangent. And we have also sine of 3x here. So what will happen? Cosine 30, we have adjacent. Okay, adjacent over hypotenuse, that is square root of 3 over 2. And then we have the sine, let's say, of 30. We have sine 30 is opposite over hypotenuse. So opposite is 1. Then we have hypotenuse, we have 1/2. Okay? So what are we going to do here first is we can directly substitute the value of pi over 3. Okay? As long as that it does not result to an indeterminate. Okay, so 0 over 0, that's illegal. We cannot solve that. We cannot directly solve for that. Or the denominator is 0. So numerator is 0, but the denominator is non-zero. That's okay. But if the denominator is 0, then that's not that's indeterminate. So if we're going to evaluate this tangent here is simply equal to tangent of x. Okay, we know squared sine of 3x over, we know that the secant here, okay, is equivalent to 1 over cosine. And we also, for the cotangent, okay, we will use some basic identities. So what are we going to do here? If we are going to directly substitute it, tangent of, let's say, pi over 3, okay, tangent of pi over 3, you know that is squared multiplied by sine of 3 of x. Okay, our x is pi over 3. Okay. Over, we have the secant of x over 2. Secant of x over 2, we have, that's equivalent to 1 over cosine of pi over, okay, let's evaluate. That is cosine of pi over 2 over 2, pi over 3 I mean, because that's our limit, pi over 3 over 2. Okay, that's our value, minus cotangent of 2 times pi over 3. We know that this tangent pi over 3 is tangent 60 degrees, so we have square root of 3 squared. And we know also that this sine 3x of x is equal to pi over t. This is simply sine of pi. Okay, sine of pi. Sine pi is actually it's actually equal to 0 because sine 180 is 0. Okay, so this whole numerator must be equal to 0. But let us take watch, or let us be careful for the denominator not to make it 0. Okay, So 1 over cosine pi over 3 divided by 2 would be pi over 3 times 1 half. So this should be cosine 1 over cosine of pi over 6. Okay? And pi over 6 is equals to cosine 30. And we can also use this, okay, wherein we have a minus, okay, cotangent is 1 over tangent of 2 pi over 3, identity reciprocal. So we know that our the numerator would be equal to 0 because 0 times square root of 3 squared is 0. And we also know that cosine pi over 6 from our special triangle here would be square root of 3 over 2. This is minus tangent of 2 pi, 1 over tangent 2 pi over 3. 2 pi over 3 would be, if we convert that into degrees, this would be 180 over pi. Pi's would cancel. We have 360 over 3. That's equivalent to 120. And we know that the angle is here. Okay, if we draw the, it is in the second quadrant, tangent 120. Okay, and it is similar to tangent 60. Okay, given because this is lies on the second quadrant and tangent on the second quadrant is must be negative. So tangent 60 is square root of 3. So tangent 2 pi over 3 or tangent 120 should be equal to square root of 3 but negative square root of 3 because it lies on the second quadrant. So that's from the trigonometry. So we have 2 over square root of 3 plus we have 1 over square root of 3 because negative then times negative would be positive. So as you can see, the denominator is not equal to 0. So we have an answer of 0. Okay? Okay, let's continue our discussion. For number 2, we have another problem here. For number 2, the limit of sine 3x over 5x as x approaches 0. So as you can see, if we directly substitute the value of 0 here, okay, in our limit, so we will be having sine 3 times 0 over 5 times 0. Obviously, sine of 0 is 0, and we have 5 times 0. This is indeterminate. Okay? So, this cannot be. Okay? So, we must find a way wherein we're going to evaluate the limit of this, okay, such that this would not be equal to 0 over 0 because that's not acceptable. So one way of actually trying to solve this is we have a trigonometric function inside sine 3x. Okay? And we must also take note, okay, by the way, I forgot, that we have a property in evaluating trigonometric functions such as we have this limit of sine of x over x as x approaches 0 is equals to 1. Okay? So, if we ever see this type of limit, okay, that is equal to 1. So, what our objective is to make this limit look like this. Okay? The x here could be 2x as long as the denominator is also 2x. It could be pi x as long as the denominator is pi x. Note that the x here is inside of sine function. Okay? So, if I'm going to multiply this by 3 over 3, that is still multiplying to 1. Okay? So, what will happen here is I will be having 3 sine of 3x over 3 times 5 is 15x as x approaches 0, of course. Okay? The limit of 3 sine 3x, 15x as x approaches, that's right. Okay, as x approaches 0. So what will happen here is, if I could factor out 3, okay, factor out 3 over 5, okay, let me just rewrite the limits. I forgot it. So we have the limit as x approaches 0. So This is valid again because we have multiplied the whole equation by 3 over 3, which is basically equal to 1. So if I'm going to factor out 3/5 here in our function, here inside function, so what will happen, I'll be having sine of 3x over, okay, I factor out 5 here, so we must have a 3x here. As x approaches a 0, okay, as x approaches 0, one property of limit is that we can factor out constant outside of the limit. So we have the limit of the sine of 3x over 3x. Okay? As x approaches 0, for this property, we apply this. This is simply equal to 1 because of this property. As you can see, we have sine of 3x over 3x. Okay? That is the same as this. As x approaches 0, that is the same as this. Sine of x over x. Whatever the value of the inside value of the sine function divided by that the same function or that the same angle, as x approaches 0, that is equal to 1. So we have the answer 3/5 multiplied by 1 because this is simply equal to 1. So our answer for this problem should be 3 over 5. Okay? Okay, let's go now to our next problem. For our next problem, we have 3, the limit of sine 2 theta over 4 sine of 3 theta as theta approaches 0. Okay, so that is our problem. So, problem is, again, if we directly substitute the value of 0 here, so that would be sine times 2 times 0 over 4 sine 3 times 0. We know that this would be 2 times 0, okay, is 0. Sine of 0 would be 0. But we have sine 4 sine of 0. So 4 times 0, okay, that should be 0 over 0, which is an indeterminate. So what are we going to do here? If this happens, most probably the trigonometric functions that you are dealing with requires, okay, identities for you to be able to solve it. So what will happen? We have the limit of the sine 2 theta. Sine 2 theta, remember that is equal to 2 sine theta cosine theta over 4, and we have sine 3 theta. That's also a property. Okay, sine 3x, that's also an identity, or sine 3 theta. That is basically equal to 3 sine of x minus 4, okay, sine cube of x. So in this case, our x is theta. So we have 3 sine theta minus 4 sine raised to 3 sine cube theta. Okay? So we need to simplify this as theta approaches 0. So if we are going to continue our solution, we can see that we can factor out the both of the sine theta here from here and here. We can factor it out. So if we factor it out, so we have 2 sine of theta cosine theta over, we have 4 sine theta, okay? We have 3, because we have factor out sine theta, minus 4 sine squared, okay, theta. As you can see, this would cancel. Sine theta would cancel. 2 over 4 would be 2 here. So what will happen is that we have the limit of theta as theta approaches 0. Sorry, let me just rewrite that. So that would be as theta approaches 0. So that would be cosine theta over, we have 2, 3 minus 4 sine squared theta. Okay? So now, if we are going to directly substitute theta as 0, so what will happen? We have cosine of 0 over 2 times 3 minus 4 sine of squared of 0. Okay, we know that cosine of 0 is what? Cosine of 0 is, yes, that's right, that's 1. Okay, 1 over 2 times 3 minus 4 times sine squared of 0. Obviously, that's 0. Okay. Again, obviously that's 0. So we have 1 over 2 times 3, that's 1 over 6. So as you can see, we have evaluated the correct value by employing some identities in our given trigonometric functions in order for us to not to arrive at the indeterminate form. Okay? So let's go now to our number 4. Number 4 problem would be the limit as y approaches 0 of the 1 minus cosine 7y over 2y. So if we are going to directly substitute y is equals to 0 here, so we have 1 minus cosine of 7 times y is 0, obviously 2 times 0, so we have 1 minus cosine of 0 is 1 minus 1, so 2 times 0 is 0. So obviously we have an indeterminate form. That cannot be. And also, if we're going to recall, we have the property of 1 minus cosine theta over theta as theta approaches 0. Okay, as theta approaches 0 is equal to 0. Okay, take note of this property. So, what are we going to do is to make this given equation, given problem look like this so we can evaluate it. So what will happen? What is the first step? The first step is whatever the angle here, we're going to get the constant value, okay, and divide it by the constant itself. So we have 1 minus cosine 7y over 2y multiplied by 7 over 7. That is still technically equal to 1. Okay? So we have now 7, okay, multiplied by 1 minus cosine of 7y, okay, over 14y, obviously, as y approaches, that's the limit as y approaches 0. Okay? So, what will happen now if we are going to take, again, manipulate this such that I'm going to have 7 over 2, that's multiplied by 1 minus cosine of 7y over, again, 7y because I factored out 2 here. So 2 times 7 is 14y. Alright, so this is now the actually the property that we are trying to get. Okay, if we factor out 7 halves outside of the limit, okay, because that's constant, that's one property of limit. Limit of 1 minus cosine of 7y over 7y as y approaches 0, we have seen it. The angles are the same. The theta is the same as the denominator and it approaches 0. So in this case, our theta is 7y over 7y and y approaches 0. We know that this is equal to 0. So this 7 over 2 is now multiplied to 0. Then we know that our answer should be 0. Because any number multiplied by 0 should be equal to 0. On to our last problem. For our last problem, we have limit of uh, tangent of 4s over 4s as s approaches 0. Okay? So tangent of 4s as over 4s as s approaches 0. Okay? We have a property to remember that this is equal to 1. Okay? Because we have the property of the limit, okay? Limit of the tangent theta over theta as theta approaches 0 is equal to 1. Okay? So this has the form for our last problem wherein our theta is equal to 4s and it is divided by the same theta which is 4s and the s approaches 0 as well as the theta approaches 0. This is equal to 1. Now, I will not show you the proof of that. That is only some properties of trigonometric functions. So again, so thank you so much for listening. I hope you learned something from this video. If you are new to my channel, please don't forget to subscribe to my channel to see the latest videos, and don't forget to hit the bell button, okay, below, okay, and to be notified if I'm going to upload new videos. So thank you so much for listening. This is again Engineer Abad. God bless you.